Okay, so Jacek Głodek, why JavaScript sucks? Applause!
Okay, so
Almost there?
so the name of the talk was actually changed by us with Piotr in Lisbon on 4 a.m. Last week. So why your JavaScript sucks is, maybe an overstatement. I hope your JavaScript doesn't suck. But I want to share a couple of tricks and tips about how to type better and how to write better JavaScript with TypeScript, and in order to make your code more maintainable and generally better. So I'm Jacek, and I'm a founder of Iterators, that is a software consultancy that's building software using Scala, so a language that is very much typed and has a lot of it's a TypeScript that is on yeah. Okay, one moment. Okay, so yeah, so what's in it for you? This is basically a beginner to intermediate level talk. You'll be able to recognize problems when constructing your own code base with TypeScript and making some decisions and not and you can learn a bunch of few concepts around functional programming, monads, and side effects and so on. So this is going to be maybe good for you. Okay, so what are the types? Types are, type is a label that we put on a data. So if this is my email, jglodek@iteratorsHQ.com, we put an email on it. That's the email is a type, the data is the string, we connect it, we get a typed variable or typed constant and so on. So basically we can connect those two. Type system is a set of rules for associating those between each other. So we don't know, if we have a number, we cannot associate string to it because that would violate the rule. That is, type should be like specific and should be the right type. If it's an email, it should be a string of a certain format, and that's the rule. Okay, so there are two types of programming languages, of course, dynamically typed and statically typed. And one, in dynamically typed systems, there are types, there are classes, there are all those concepts, but not necessarily enforced. And in statically typed systems, like what you can do with TypeScript, the types are actually enforced by the compiler or transpiler and so on. So type checker, basically, that will check if your types are well done. Okay, so two things. Enforcing type integrity will give you feedback about your system consistency. So basically, you will know if the app is integrated well and so on. And together with functions, it also makes coding very predictable because you don't have to. It's so much easier to reason about your code because you don't have to think about all the other types that your data is not. So less work for your brain. And important thing is like it can help you and it lets you build it right way. You can also mess it up and get into problems. Even if you do use TypeScript, which is statically typed, you can also mess it up. Okay, so what we often don't do, what we should do, what we can do. Basically, the agenda is I'm going to give you a bunch of examples of how to mess it up and maybe a couple of examples of how to figure out a solution. So the types can be they can be too primitive. They can we can unmarshal the data that the user provides us in the wrong way. There's hidden effects of the functions that we write, which makes them not functions. We can monkey patch around the design around type design problems, which I'm going to talk about. And there's a certain reality of that comes with being productive writing types and making readable code writing types and so on. So this is what I'm going to talk about. Cool. So primitive types, you know, the strings, number, enum, stuff like that. Pretty simple. What is the problem? If we have, if we write our TypeScript and we do like interface user, it has names, name, email, bio, password hash, and we put all of those things as strings. We don't necessarily handle for the situation when those are not really, you wouldn't call that a user. If it has no name, no email, no bio, no password hash, this is not really a user. And you try to have a system when you get the user in your system, you want to know, okay, that's a user. That's not something else. That's a user. So this situation right here doesn't solve for it because the name can be empty string and so on. So another thing is like if we use those primitive types, you see the constructor here for the class user. It's pseudocode. So we have name string, email string, bio string. So if we switch the names, like name and email here, like it's an error, like but it's gonna work on the run. We're gonna catch it in the runtime, but not necessarily. It's not gonna be caught by the type checker, right? So again, we use types, but not really. Okay, so what if instead of the strings, stringly typed things, we use actual types for all of those? So name is a name, email is an email, bio is a bio, and get type checking error, right? That would be much better. And right now with the cool libraries that are available, we can actually do that and never ever. And when we get the user, we don't never have to think about whether this user is like has an undefined anything or empty something. So that's a nice thing. So it's kind of value dependent types. And that means that you will not be able to assign a type or the type will not exist, how you call it, for a given thing. So there's no empty name. There's no email that doesn't conform to the format. It's not an email. It doesn't occupy the type. You cannot label gibberish with label email because type checker will check that. Or it will also can check that during the runtime if it's the right library. Okay, so imagine this. We have this, how can we solve it basically with really simple solutions? So there's a library called runtypes, and it's very exciting, and I try to use it a lot when writing my code. We have email validation. Basically, there's a function that will check if the email is valid. We can create a type that's basically going to be string with brand email, and with constraints that's going to be checking if it's an email or giving you an error that that's not a valid email. That's as simple as that. This is all you have to do basically to have a type that is an email, and you can extract an actual type that you can type things with it. So it's pretty cool thing that those like email is gonna be just handled by that, and you will never get the empty string email again in your code. And you can trust that if your function accepts email, it's going to be actually email and not null or anything else because of type checking and so on. Okay, so let's see. Given we have this function, we can do email check. If someone at example.com is an email, we have a password, we can check the password, and sign-in email password will work okay in runtime and during type checking. Sign-in password email, because those are two different types, will fail, so that's good. If we do a typo where we switch the order of the parameters, that's going to be fine. And we have also type type error here if we use just a string, and we have another version when we have email check UUU, and it's gonna also fail during runtime. So it's gonna work, but it's gonna check the validations on the type, and not there's not gonna be type if it's not actually email. Okay, so run types, very exciting. I highly recommend getting to know run types. Okay, so unmarshalling. Unmarshalling is a process of taking the data out of a request and putting it into your internal representation. So basically, you get a HTTP request on the one side, somebody sent you something to your Node.js server, or you received something from the server or whatever. You transform it into your own domain object or just domain representation for your stuff. So, like you have, so yeah, that's not yeah, unmarshalling example. We have HTTP request bodies, so like data, we parse them, we put them into a DTO like a user, and that's it basically. That's unmarshalling. But we want to do it in a safe way, and well, I don't know where did this go. So something. Sorry about that. Anyways, so the idea here is we want to do it in a safe way. If we cannot trust the user to provide us with right data, with right emails, with right usernames, not empty strings and so on, but we can, because we have the types and we can check every time if it's the right thing, we're going to get an error, we're going to get exception that it's going to basically fail. So somebody gave us an A for email, we get a runtime exception that didn't work. But also, if you have a function and it returns, you have a function basically, yeah. Okay, well, I'm going to go back to this. Sorry. So exactly, we cannot, if we have expected result of a function, for example, email should give us, if we process emails, we should get email and not exception, or maybe email or failed email processing error, but not like exceptions that gonna use, it's not a type. Exception is not a type that is returned from the function, it's something beyond functions, and we don't want to go anywhere beyond functions technically when doing functional programming. So the result of the function should be either an email, if we process email, or some kind of other type that says that this failed. And we cannot expect the user to give us the right data. Okay, so we need to embrace the errors. Unmarshalling must embrace bad input. Bad input is not an exception. It shouldn't be handled by exceptions. It's not like you run out of memory or something. We should treat it like a normal situation, and it's super easy to do that even in TypeScript. So let's do that. Okay. So what do we do now, right? We have an expected exception, which is just the wrong email. And we don't want this, exactly this kind of runtime exceptions to travel through our application, destroy some components, maybe some React rendering and so on, give us 500 and destroy the whole thing. We wanted to handle it properly using types again, and not exceptions and try-catch and stuff like that. So we can use monads. Monads is a thing that you can put things into and transform it within certain context. So for example, here we have a try monad. Inside the try monad, we create an email, and it's gonna check if the email is right. And in the first case, it's the output is email option, but it's not email technically, it's email monad. And it can be successful or not. And in the other example, it's not successful, but also it would be, so we turned this exception, which is like very annoyingly traveling through our like functional stack. We turn it into a type, which is the email monad, email option, like try monad. And we don't want to do like, if email monad is successful, then one thing or another. the powerful thing about Monads is that it has like a great interface for handling all the different cases, whether it succeeded or not. You can just go on and transform the data, even if it failed, and it's going to account for that. So basically, you have this kind of situation. Imagine we do stuff with email, so we transform email into an email or any kind of type. Inside this function, we can trust that the email is actually the email that we created earlier, and we can return any other type that we'll also know. It doesn't have to be email, but that we will also know what's happening to the type. And inside the monad, we can map it, right? So we can map whatever is inside the monad, which is some kind of email, maybe my email that was, or if it was wrong email, it's gonna still work. We can still call do mail stuff, and it's still gonna work. So there's three functions here. One is map. It's a maption that's gonna give you the email that is inside the monad and turn it into and basically turn it into another email. We can also just replace the whole monad with another monad. We can also handle some exceptions inside the thing. So I'm going to show you really quick an example. If we try to subscribe to some kind of newsletter, right? We get a user input, which is a string. We don't know if it's really working. We want to respond with our monad, because this is kind of what you want to do. Use monads everywhere, basically, because everything can fail inside the function. And here we try to create the email from the user input. And if it succeeded, we get the email, as you see. I'm not sure okay, I have a point here. So we get the email, and then inside when we get the right email, this is true email, the true type that we know that it exists. This function inside will not be called for any other option if it's not real email. So here we can get the email service, we can subscribe this email, map it into some HTTP response, and else we can handle some error. If it wasn't really an email, we can just handle it with just HTTP response of an error. So that's monads, and we don't have to. This is all types, no try-catch stuff, and very safe. And also it makes it, if you construct it in the right way, it's going to be very readable to understand what's going on. If you get used to this flat map and handle stuff, it's going to be really simple to reason about it. Okay, so I recommend not using try-catch finally if you want to create functional apps, because functions should return actual value and not throw something outside of the scope of the functional paradigm. And you can use monadic types for handling errors and so on, and embracing the errors as the normal types. So that's great, because the errors are user errors and many other errors are to be expected. Okay, so again, use dependent types. We can use the monads, map and flat map. Let's not use this if email is valid and so on, because it's pointless. We're gonna get into like the if hell of just multiple ifs and so on. And especially right now, if you don't use any kind of monad or functional programming or types, you will need to check for like if email is not null, if it's undefined even. So that's pretty bad, right? And with this dependent types, you know, this branded types from run types, you don't even have to think about it. Okay, and yeah, embrace invalid input inside the business logic. This is normal situation, nothing fancy. Okay, I don't know why every second slide has this monkey punch. Okay, so another thing that you can mess up is refactoring around type systems. So we have like user with ID, email, and avatar URL, but now we want to create a new user form. So we kind of, what's the easiest solution to have we have a nice type. Let's say this is a nice type. It's the type with runtimes, whatever. And we want to do like, but at the beginning, when I create a form, I want to have like everything should be optional because it's still not, we don't know if it's there. The user didn't yet provide the email and so on. So yeah, so we just add optionals to each and every type, each of the fields, right? Which is bad. We've saved so many lines of code. We don't have to do like a lot of typing, but you know, saved so many lines of code. But in the rest of the system, you stop being able to trust that email that the user here is still a user, because maybe it's the different type of user that can be nullable and so on. So in order for you to like reason about the code, you need to trust your types, and so the types need to be pretty like well defined, and we cannot go around those things. So definitely don't do that. Right. The other solution is just to add some types, which can be a hassle, but definitely with that approach you will be able to trust it. Also, moving forward in your programming career and your stack getting more mature, you're gonna have so many more types, and the libraries are getting so much better, right? like the ones I mentioned a moment ago. Okay, so the last thing is hidden effects that also mess up the way that you can trust in your system, which is like, I had a situation where I get this kind of method somewhere, and it was like get user with user ID. Okay, that's gonna give me a user, maybe a promise of user, like or something. Maybe it's gonna be asynchronous. Doesn't really matter. The problem is what it really did was like it was trying to fetch the user from the cache or reload it from the backend, and if it actually reloaded it from the backend, the backend sent a bunch of emails and updated some stuff from Google, and that's not the scope of get user, definitely. So the hidden effects are terrible, and maybe even naming the function with like whatever it really does is going to be good kind of push towards refactoring this piece of code, because this is like pretty terrible thing to do. Unless you do it, I mean, it's terrible. Okay. So if you run this function and you get like null or whatever, you don't know if user doesn't exist, you know, or the Google thing failed, or geocoding failed, or whatever. You don't really have the feedback, or you just get some exception. But get user in your head, when you're trying to reason about it, it should be like, oh, okay, there's no user or something. And it can be so much more because you have so many side effects and so many like arcane logic inside that it can fail. Okay. All right. So the idea is that we do referential transparency in functional programming, and referential transparency is exactly that. For every input that you get one output every time you call the function. So this is really like pure functions, right? One parameter, one function, same parameters, the same output. And that's, in that way you can reason about it, because you can trust that it's going to be actually doing its job and not doing something else behind the scenes, right? Okay, so that was the referential transparency that I talked earlier as well. So that's very important to just keep it very brief, and because you see the subscribe request at the end, you can trust that it's going to be just transforming this user into subscribe request, and it's not going to do much more work beside this. Else it's side effects, and you don't want to send emails in your tests when you're trying to just create some stuff. Okay, so programming with types, real talk. There's definitely trade-offs and not. So this is pretty much the and so productivity, dynamic types. You can like prototype away. It's great. Early stage projects, it's super good. You start typing in the middle somewhere when you don't have right libraries, and you kind of type, and bunch of stuff is not typed, the productivity falls because you need to type a bunch of stuff, but then you get a lot of errors everywhere in your app, and it's bad. But when you kind of go far away into like typing land, your productivity is really boosted. And especially when in like dynamic languages, the productivity at the like long-term productivity can fall if you don't do a bunch of tests, which is also like pointless for some of the types, of the test for the typed system. The productivity is higher because you can maintain stuff, you can trust that whatever you're looking at is exactly the thing that you're looking at. And yeah, of course, the safety is better. And while in dynamic languages, you have to like test everything, types handle partially some of your tests for you. You don't have to check if user is not a carrot and so on, because that's handled by default. When it comes to readability, like it's weird. Like in dynamically typed systems, when you have like really good libraries and metaprogramming, you can go like really readable code. Like that was the case for example, Ruby on Rails or something like that. That like super short code, super big, like super lot of productivity, very readable. Not so safe, because you can play around and monkey patch around a bunch of problems, and that's going to be bad. And in typed system, you can either have great readability with monads and so on if you design it right, or you can go to like it's going to go like be terrible if you go too much into like category theory and start thinking about using concepts from like mathematics in a wrong level inside your code. Then you also can mess up, because only like PhDs with mathematical degrees can help you write your code, which is also pointless. Okay, so thank you so much, and I'm Jacek from Iterators, and hope that was helpful.
Congratulations, Jacek. Great talk. Do we have any questions? Any questions? There is one. What's your name? The question is going to be asked by Mateusz. 1, 2, 3. Can you hear me? Okay. At the end of your presentation, you mentioned that we shouldn't return null type if the user is not found. How we should handle those situations then?
Okay, so we have many monads, and some of them are like result monads. Like you have or either monad, and that means whatever is inside the monad can be either successful or not. So inside the monad, you can, like, if it succeeded, you're gonna just transfer whatever succeeded, right? And if it failed, like which was the case here. 1 second. Which was the case here. If there was an error, we're gonna get another thing. And you can technically do any like really complicated types inside. I mean, get user can be like can result like result monad of user or error fetching user type, and you can transform. And in this like map function, you're gonna get the user, but in the handle function, you will get the error fetching user type. So you can have just many more types, like user or user not found error, and that's going to be the 2 types that can be returned instead of null. Which I'm not saying. You can have a result monad that will handle all kind of stuff. Even if it's null, you will know that something failed, but it's not necessary for you to really type it. It's just gonna work with the monad. If it didn't work, you got a null as a result of some database fetch, your promise resulted, or in like failed promise or something like that, fails asynchronous request, then it's going to just go with another flow of computation, because there's a successful flow of computation and like the other flow of computation that you can even recover from, right? Like catch, and you can still return a proper promise.
All right, amazing. And one last question, because we're going to have lightning talks and there will be pizza. Oh yeah, all right. So you first.
Yeah, so question, because I first time hear about this monads. Is it a construct that's something from Scala that it's supported natively, or because I just talked this try-monad library on the GitHub and there is just one star, so maybe it's wrong one.
Yeah, so I took the try monad because it is only one monad and it's really easy to see how it works. And they're better. I use different types of different monad libraries, like TypeScript monads. They have a bunch of more monads. They have like 40 monads. It's you need to wrap your head around the monad, but yeah, it's not new at all. It's Scala uses them heavily. Every functional programming language uses them heavily. It's mathematical construct.
Okay.
Just put something in a jar and you can do whatever with the jar. You can shake it. You can add more stuff to it, but it's still gonna end up in a jar.
Yeah. That concept is well known, but I just wanted to ask about this model itself. Is it some library or something? But okay, thank you for
Many libraries.
lighting.
Right, so applause for Jacek.